Welcome back. Let's start the two-dimensional slicing since it is a little bit tricky and I have seen this is being used in lot of the projects. So that is why I wanted to start off fresh. So let's start. In line 89, we have defined the two-dimensional data, and line 92 is little bit tricky one. So, and before I explain line 92, if you recollect, anytime whenever we are saying something like this, something like if you see the typing 0 column 3. So what is the meaning of this highlighted part? This is a meaning that start from 0 and get me everything till before 3. Not 3 is not included. It means 3 is exclusive. 0, 1, 2. It means get me only these 3, not the third one. This is the first. Yeah, you got it. Now when I write like 3, it means get me the third element. Here 3 is inclusive. Get me the third element. It is not having any other meaning. Similar way, in line 92, when you get the data, it says this first one, get me all the row, and this says get me all the row till last. But if you recollect, whenever we say till last, it means it is exclusive. Don't get me the last one. And it says get me all the row, and then this is the last column. So let us run it. Let us run and see. And if you print the x is basically all the row and all the column except last, that 33, 66, 99 is the column. So this is what. And if you print y, that is your last column. So it is the last column. I hope you understand. Good. Okay. Sometimes you have to split the data. Split the data means basically take to the certain number row in one and the remaining row in the another things. Excuse me. In line 97, if you see, I have just kept the split data as a 2 and then train and test. So what it is saying, let me run it first. And then you see. So what it is saying, this data has been splitted. The first two row is in the train and the next one row, or basically after 2, whatever row is left out is in the test. Here it is only 1, so that is why you see only 1. So this is the horizontal split. This was your vertical split at the last column. This is the horizontal split. Top 2 row in the train and the remaining rows in the test. So this is also one kind of a split. Good. Now there is something called reshaping. Reshaping is basically, if you see that till now almost all the Numpy array, they have something like if you see the shape is like 3 comma something. So let's see that why the reshape is required. Reshape will be required. Some of the algorithm, especially in deep learning, they need the shape explicitly. Basically, if it is 3 comma something, they need, even though 3 row 1 column, they need 3 comma 1. If you have 1 row 5 columns, say 1 comma 5, they need explicit all the dimension in case of deep learning, and few of the algorithm also need explicit. So that is where reshaping is required. But let us see that what is the number of row and column of the data. So if you see, the number of row is 3 and column is also 3. That is fine, perfectly fine. This is where it has been defined. Okay. Now when you want to reshape it, so let us see first start the reshape. Let's start the very first one with 1 dimension. Let's start with the very basic, the 1 dimension. In case of 1 dimension, if you see, it is a 5 comma something, which is the in terms of simple English, yes, anyone can understand it is 1 column, that is fine, but algorithm do not understand. So that is why in case of line 121, I'm using the command called reshape. So on data is your numpy object, reshape, and what is the new reshape value? This is the same number of row what it was, and the column is 1. Instead of nothing, it is written 1. So let us run this 121 on 122. So this time if you observe, this is 5 comma 1. Previously it was 5 comma nothing. This is the reshape. This is what the reshape it does it. In terms of this two-dimensional reshape, let us see the reshape again here. So this is the very basic. It is the 3 comma 2. But generally what happens? It is the, if you want to make it a 3 dimension, it is the actual number of row, that column, and one that's it, third dimension. So if you make the third dimension over here, basically change the dimension. If you see, this is the shape. So 3 row, 2 column, and that is the third. So in this way, how do you read this? Basically, the third dimension is only 1. So whichever way you want to read, so there 3 dimensions have been converted. So you can convert you can change any number of dimension, and the data will also change like that. Now let us do a little bit of classwork. So you can pause the video and let us do one classwork where you have to find it out mean of the neighbors. So what is the meaning of mean of the neighbors? So basically if you see that this is the data you have. This is the data you have, line 132. You have to figure it out. What is the mean of the neighbor? What it means? 11 plus 22 divided by 2. What is the mean? And then 22, 23. So please see that how can you do it. And if you find difficulty, I have given the hint also over here. This one you can figure it out how to figure it out, the data till 24. Data till 24, basically till this point, and then data from 22 from here. So what it means, you can have the two array, one from 11 to 44 and another from 22 to this much. Then you can find it out the mean. This you can do it. So if you don't do it, you can put it in the discussion board. I will help you out over the code there. Let's start the stacking in the next video, because this is also one of the important things. So once you do this, once you complete the this one classwork, please start the next video. Thank you for watching it. Let's see you in the next video.